All right, lastly, we come to homeostasis, and homeostasis is extremely important for living things. Homeostasis is the body's mechanism for keeping stability or keeping an internal balance. Properties that require stability include temperature, so like when you get hot, you sweat, when you get cold, you shiver, salinity, acidity, nutrient concentrations, water levels. So when you're dehydrated, your body has mechanisms to try and prevent water from leaving your body, so on and so forth. Okay, so we've got here are some examples of control centers, which we'll get to in the next slide, that impact homeostasis, the different parts that help with maintaining that balance. Here's an example going from start to finish. Blood glucose levels rise, pancreas releases insulin, the body cells take up glucose, the liver takes up glucose, blood glucose then declines, and we get back to homeostasis. So, depending upon the scenario, will determine how many things actually respond. But there's always a set point. A set point is like the normal conditions for stability. We've got a nice little image over here too. The receptor senses the change in the body and compares it to the set point. If it's too high, it'll relay that to the control center, and then the control center is going to receive the signal and determine how to respond. If levels of something get too high, the control center is going to then take that information and decide how to respond, send it to the effector, and the effector is going to take the message from the control center and make the necessary adjustments to keep stability. So it's kind of an ongoing thing until you get to balance. If it's not balanced, it's going to continually go through this pathway. But once you receive balance, then it'll stay consistent. It'll just stay put until the next changes are received from the receptor. Positive and negative feedback. So changes can either cause more changing, which would be our positive feedback, where the response continues to change. That might be like your body can sometimes create a fever in order to fight an illness. We have to monitor that to make sure that the temperature doesn't get too high when you are on a fever. And then we do things to help bring that fever down. Fevers can also be caused by bacteria and viruses too. So don't get that confused. If our body is creating the fever, then it's the response to help fight the illness. But sometimes the illness can cause the fever too. So there's two different ways that can happen. Um, an adrenaline rush in the case of fight or flight. So when you get scared, when you're in a dangerous situation, if somebody's hurt, like you have an adrenaline rush, and that's going to continue in a positive way until that fight or flight scenario or the person in danger has been to the point that they're no longer in that situation. And then the adrenaline rush will come back down. But if you have that situation, you'll get an adrenaline rush, which will be a positive feedback loop until that stimulus that's causing that response goes away. Negative feedback is the opposite. It wants to reverse the change. So, like when it's hot outside, we sweat to help us cool off. If you eat too much sugar, the blood's going to send insulin into the bloodstream to help the cells absorb the sugar so that there's less in the bloodstream, so on and so forth. So, there's different feedback loops depending upon what the body needs at that point in time. Here's an example of some feedback loops. So, the body's constantly keeping an eye on its temperature. If it increases, it's going to sweat to cause it to decrease. If your body temperature decreases, you're going to shiver and have other mechanisms to help increase the temperature back to where it needs to be. So, depending upon what's going on, will determine what kind of feedback is going to occur.